Hello, pre-algebra class. I'm so excited to be making another episode of Mr. Chow Time. Here we are doing adding and subtracting unlike fractions. This is lesson 17, page 126 if you're following along in the book. Adding unlike fractions. So anytime that you're adding a fraction with a denominator that is not the same, for example, here we have a 3 and a 2, then you need to make them have a common denominator. You can only add or subtract fractions that have the same denominator. So how can we do that? Well, you can, one way is just to multiply these two numbers together. You will always get a common denominator if you multiply them together. If you do that, though, sometimes you'll get a denominator that's large, and it would be better to not do it that way. And the best way to do it is to find the least common multiple. The least common multiple. So the multiples of 3 and 2 are 3, 6, 9, 12, 15, so on and so forth. These are called multiples. The multiples of 2 are 2, 4, 6, 8, 10, so on and so forth. These are the multiples of 2. So you can see here, 6 is the smallest of the common multiples, and so 6 is the number that we use. So 3 times 2 equals 6, 2 times 3 equals 6. So you have to multiply this by 3 over 3 and multiply this by 2 over 2. Remember that if you're multiplying a number by 2 over 2 or 3 over 3 or any number over itself, then you're basically multiplying by 1, and you don't really change the number, you just change the form of that number. So if you multiply 2 over 3 by 2 over 2, and then 1 over 2 by 3 over 3, then you get 4 over 6 and 3 over 6. Then you can just add the 4 and the 3, and you get 7 over 6. I will accept improper fractions as answers. I will also accept mixed numbers as answers, but they always have to be simplified. You always have to reduce your answer. Okay? Okay. An unlike fraction is just a fraction with different denominators. So here we have a couple of examples. 3 over 5 plus 1 over 3. The least common multiple of 5 and 3, you can just make a list: 5, 10, 15, 20, 3, 6, 9, 12, 15. There it is, 15. Right? And for most of you, you won't have to write out the least common multiple like this. You can just figure it out by looking at the numbers. I'm just writing it out just to make the extra time in the video. I know you appreciate watching really long videos. So we're going to multiply this by 3 over 3, and we're going to multiply this by 5 over 5. And we'll get 9 over 15 plus 5 over 15. And that equals 14 over 15. And 14 over 15 is, it's simplified. So we can just leave it just like this. Here we have 1 over 6 and 3 over 4. So the least common multiples, the multiples are 6, 12. Oh, I'm just going to stop there because I know that 4, one of the multiples of 4 is 12. So we'll multiply this by 2 over 2 to get 2 over 12. And then we'll multiply this by 3 over 3, right? And that'll give us 9 over 12. So here we have 11 over 12. Once again, it's already reduced. You don't have to do anything more. So convenient. Your turn. Find each sum, write in simplest form. Okay, so here, this is as easy as just doing the left fraction, because the right fraction, we're going to use that 10, the denominator of 10, right? So we don't have to do anything to that. So it's going to be 4 plus 3 equals 7 over 10. Here is the same. We don't have to do anything to the right side. We're only going to multiply the left side by 3 over 3. And that'll give us 9 over 24 plus 5 over 24 equals 14 over 24. And 14 over 24 can be reduced. They can both be divided by 2. That'll bring us down to 7 over 12. And that is reduced. Okay. Moving on. Remember that when you're dealing with negative numbers, the positive and the negative number, they basically cancel out, right? So if you have a number like negative 5, 6 and then a positive 1/8, they're on opposite sides of the number line, right? So for whatever negative you have and whatever positive you have, they're going to cancel each other out. And then the one that ends up being the bigger absolute value will end up winning. So let's just do it. The least common multiple here is going to be 24, right? 24. So 6 times 4 is 24. So it's going to be 20. And then here we have 3. So it's going to look like that. And then, so we'll have negative 20 plus 3 is negative 17. Oops, I didn't leave myself very much room there. Over 24. Negative 17 over 24. Here we have a compound fraction, so it needs to be converted to an improper fraction. So we're going to multiply these and add these. So that's going to be 10 plus 1 is 11 over 5. And then 15, 19 over 5. Now, sometimes you're not going to get the same denominator, in which case you'll have to convert it at that point. So here we have 30 over 5, which is the same thing as 6. All right. Good job. During your turn. Oh, no, that was not your turn. This was me giving an example. Now it's your turn. Write the sum in simplest forms. Okay, welcome back. Here we have 6 times 9. That's, what is that? 54. 54 plus 8 is 62, right? Am I right here? 62. 62 over 9. It's going to be a negative. I'm going to get rid of that just to clean things up over here. Oop. And then 7 times 12 is 84 plus 5 is 89 plus 12. Okay, so here we have, I don't know what it's going to be. I think it's going to be 36, right? Yeah. So we're going to multiply this by 4. Oh no, what's 62 times 4? Oh, I guess I'll just do it over here. 62 times 4, 8, 24. So that's 248 over 36. And then this is going to be times 3, right? So 89 times 3, 27, 24, 25, 26, 267. So 267 and 248, these are opposites. One is positive, one is negative, so you just simply subtract them. So that gives you 19. And which one wins? 267 or 248? 267 is the bigger absolute value. So it's going to be a positive 19 over 36. 19 is a prime number, so there's nothing to reduce here. All right. So here we have 15, 18 over 5 plus a negative 29 over 6. And then this is going to be 30. So times 6, 18 times 6. What is that? That's 48. 108. Is that right? I hope so. 29. Yeah, 29 times 5. What is that? 45. 45, 14. 145. Okay. So here again we have 145 minus 108. 15 minus 8 is 7. And then 13 minus 10 is 3. 37. 37. 145 is bigger. So, oops. 37 over 30. I would take that. I would also take negative 1 and 7 over 30. Okay. Wow, this is taking a long time. Okay. If we're subtracting, it's just like adding. You still have to get the denominators the same, and then you just subtract across. So, let's take a look at an example. Subtracting fractions with unlike denominators. Okay, so we have to get these both to 8, right? So we're going to multiply this by 2 over 2. And this is going to give us 6 over 8. 3 over 8 minus 6 over 8. That's negative 3 over 8. This is simplified. Here we're going to do it again, but we're going to turn this first into an improper fraction. 5 times 9 is 45, plus 3 is 48 over 5. And then we're going to subtract, this is 21. 21 plus 2 is 23 over 3. 15 is our LCM. So we're going to multiply by 3 on this side. 48 times 3, 24, 12, 13, 14, 144 over 15 minus, and then we're going to multiply by 5 here. 23 times 5 is 15. 10, 11, 115. Okay, 144 minus 115 is 29. Am I right there? I hope I am. 29 over 15. Can you reduce that? No, I don't believe you can. Okay. Or you can write that as 1 and 14 over 15. Either answer works. Your turn. Okay, welcome back. I'm going to try to do this quickly. 7 times 6 is 42. 43 over 6. It's funny because I'm not going to do it that fast. 48 plus 5 is 52. 52. No, 53. 53 over 8. Oh, now I'm doubting myself. 48 plus 5. Yeah, it's 53. 53. Okay. 6 and 8. What did we say that was? That was 24, right? 24. So this is times 4. 43 times 4. I should be using a calculator for this. 16, 17, 172 times 3. 53 times 3. That's 159. 159. 172 minus 159. Oh, that's 3. That's 1. 13. 13 over 24. And then 15, 16 over 3. Plus a negative is the same thing as plus. 4 times 9 is 36. 36, 41. 41 over 9. This is going to be 27. Yeah, 27. Oh, wait. No, it's going to be 18. No, it's not. Yeah, it's going to be 18. Okay. 18. Oh, okay. So times 6. Times 6. Am I right here? Yeah, I'm right. 16 times 6. 36, 96, and then 91, or no, this is 41. This is a 41. This always happens. Yeah, 41. 41 times 2 is 82. So that's 178 over 18. And I'm not going to turn that into an mixed or a compound number because that just is going to take too long. Okay, this is real life now. To set up a computer network, a network is when you connect computers together through a server. We're doing this at KAS. This is how we get all the computers at school to connect together. A 100-meter cable is cut and used to connect 3 computers. Of course, we do this wirelessly with wireless routers, but those wireless routers are connected with wires. So anyway, we started with 100 feet or 100 meters. And then we connect these 2 computers here. Let me get my pen out. We connect these 2 computers here. And how much cable do we have left for the third one? So this is going to be 100 minus 19 and 1/8 minus 40 and 3/4. Oh, so good. This is going to be great amounts of fun. And remember, 100 is the same thing as 100 over 1, right? So let's turn these all into fractions first. So 8 times 19, I should know this, 72, 152, 153 over 8, because we have to add this 1 here. And then we have 160, 163 over 4. Great. And then we're going to turn these all into 8s. And so this is going to be 800. And this is going to stay 153. And this is going to be 326. I hope I'm right. Dear Lord, I hope I'm right. Okay, so let's just use the calculator. 800 minus 153 minus 326 is 321 over 8 meters. But that's not good. We should change this into 40. 8 times 40 is 320, and then we have 1/8 left. 40 and 1/8 meters. Guess what? Now it's your turn. This is real life. At a recent long jump contest, Mr. Chow jumped 21 and 1/3 feet. I know that sounds like a lot, but I have really powerful legs. Mr. Jitesh, he's almost as good as me. He jumped 20.5 feet. How much farther did I jump? How much farther? So, figure this out. Welcome back. Okay, so I jumped 21 and 1/3 feet, and Mr. Jitesh jumped 20 and 1/2 feet. So 3 times 21 is 63, plus 1 is 64, over 3, minus this is 40, 41 over 2. The common denominator would be 6. So this times 2 is 128. This times 3 is 123. All right, so we subtract 128 and 123, and we get 5. 5 over 6. 5 over 6 feet. That's how much farther I jumped. yes, please congratulate me, and let Mr. Jitesh know. He's got to work on his long jump. And you don't need to give him any more information than that. Just tell him, work on your long jump. He'll know what's up. All right, have a good day. See you in class.